Hi everybody, and thanks for joining us here. It's always a very good experience for me, basically, to be able to talk with the Redis community, because what keeps me going after 9 years is the fact that Redis is used by many people in order to fix, at the end of the day, business problems. So, for example, when I search a question in Stack Overflow, I know that there is Mark, which is doing something with Redis in order to make me able to do that. And we collectively form a community that basically try to keep the world, the technological world up. So basically, thanks for joining us, and I hope that we'll have the opportunity to talk face-to-face in order for me to explain what's next, to explain me what you expect about Redis in the next months and years. So in this talk, I will talk about the future of Redis, like the short-term future, what you can expect to see in the next year. Of course, this kind of schedules are never perfect, so we will be able to do something, we will not be able to do something else, and especially there will be new ideas popping in the course of the journey that are not shown here. But I believe that there are good ideas for the future of Redis in this presentation. The big thing in the new release, which is going to be a release candidate in a matter of weeks, is the streams. The stream data type was a very huge hole from the point of view of Redis data structures. When you approach certain problems in Redis, you say, like, okay, let's use a list, but actually it is not exactly the right use case, doesn't work very well, and then you say, maybe a sorted set, and also there is some problem, but I could use maybe publish, subscribe, and you find that there is like a number of problems that you can really not model quite well, like time series, or when there is a need for event sourcing. So I believe that streams were really needed in order to make Redis a bit more able to solve certain things of problems. Also for IoT, messaging. For example, if you want to implement something like the Slack chat on top of streams, it becomes a much simpler problem. If you try to do it in Redis 4.0 without streams, you have like to find your way in order to make it working. But there is an in-depth session about streams where I will explain all the details about basically the implementation, the design process. So no longer talking about streams because we have like 45 minutes later. One thing that I understood in my last trip in Tel Aviv is that there was this room full of people doing modules with Redis. Redisearch, Redigraph, and more. And basically, my colleagues were not very happy about certain things in the Redis Modules API, because it's quite good, but it's clear which it requires more work in order to get better. The problem is that the fundamental problem of the Redis Modules API is that I was not eating my own dog food. Simply, I am not a user of this API, and the reason is that I started a module a couple of 1 year ago or something like that. It was called Neural Redis, 2 years ago probably. It was like fully connected simple neural networks that you could train inside Redis. So Redis didn't work like an appliance for neural networks, but you could learn new things in the networks using the new data arriving in Redis in real time. I thought that it was a very useful concept because these neural networks are very simple to train. It uses an algorithm which is called RProp. It's a kind of backpropagation. And every neural network is very small. So you can have, for example, one neural network for each user, modeling like some kind of interaction or something like that. But the idea, unfortunately, never was well received by the community because, you know, today people are used to very complex neural network setups. And if something is not cutting edge, it's like ignored. But still, it was so simple to model things with neural Redis. For example, this is an example of, a typical example of machine learning where you want to do sentiment analysis. You have movies reviews and you want the neural network to learn basically if the review is positive or is negative. So the benchmark in this area by the most advanced neural network currently available is basically 92% of correctness. In neural Redis, after 2 minutes of like playing with it, I got 80%, and you probably it's a plateau. You can get better than this, but the point is that it makes machine learning very easy. But still, people didn't like it, so I abandoned the project. Maybe someday I will do it again. So I no longer have a module. What I do in order to be again one of the users of my API, well, fortunately there was a project which I started a couple of years ago, which was a fork of Redis, creating a messaging system, and it was called DisQ. And people really loved it, because it's a message queue like RabbitMQ or Amazon SQS, but it's like very, very powerful. It's a distributed AP system with strong guarantees about message deliveries, and it is federated, like if one node is full, messages are transferred automatically to the other node, it's synchronous replicated, it worked very well. So I released the release candidate, and then I abandoned the project because I realized that the fork of Redis was too complex to maintain. Every time I made a change in Redis, which was common with the code base of DisQ, I had to merge the code back in DisQ. I said, this is a nightmare. It's better if I write a module system which is powerful enough so that I can port DisQ as a module of Redis. And finally, I started this project. And as a side effect of eating my own dog food, basically, I implemented the new things finally in the Redis cluster, in the Redis Modules API. One is a cluster API. So basically, if you have a Redis cluster, even if you don't use like the Redis cluster as a store, you can use the Redis message bus in order to send messages from your modules in order to create a distributed system. You already have like send to, broadcasting and all this kind of failure detection of nodes, and you have an API for modules in order to do that. And also timers. A very scalable implementation of timers. You can register like millions of timers in a single module, and there is a scheduler firing a callback. And this is also very important when you write complex modules to have timers. It uses the cluster internals, but it's not Redis cluster. You can basically write a module using the cluster API, which has nothing to do with Redis cluster, like DisQ. Basically, what I want to do is Commodore 64 for distributed systems. Like that, without doing any effort, like inventing a protocol, inventing a message bus, having data structures, you just code the minimum that basically makes the logic of your distributed system, and that's it. And this is what I'm doing basically with the DisQ port. I'm trying to make this API good enough. Yes, I told about this. You avoid doing basically a lot of things. And the status is that currently I am yet not able to release DisQ in the current state because I wanted to do it as an April Fool, like in 3 days. And I realized that it was a massive work. I spent more 2 weeks of work in order to present DisQ as a module at RedisConf, and I completely failed. It was still too much work. But eventually I hope that I will be able to do it. Because at this point I am very near. Everything almost compiles. There is a single file, and then I will run the tests. And okay. About the release of 5.0. One problem that a mistake that I made with 4.0 is that I released it too early, and there was a bit too much technical depth in the release. So basically, I said, okay, finally 4.0 is GA, and then like 3 months of fixing bugs. So I don't want to repeat this sad experience with 5.0. I believe that release candidate will be out in a matter of like a few days. But then in order to go for GA, I want to see it to get stable, to get tested. I want to see users starting to use streams. Actually, I believe the streams are very, very, very stable, but not consumer groups. Consumer groups is new code, and I want to see it to be more tested, and I want to write more tests. But in general, we should have GA as soon as possible. It's a process. I cannot like know right now what's the timeline, because it's a matter of the frequency in which new bug reports are sent and the speed at which I can fix them. So the other big thing in Redis land for this year is threading. At start, I wanted to make Redis threaded, like the I/O completely threaded and things like that, in order that for a single process, basically to exploit multiple cores. I/O threading is basically something like that. There are all the clients get sharded among different threads, and then there is the key space, which is, of course, must be locked, because from the point of view of the outsider client, every operation should be like ordered. You send an operation, it's applied to the database, the second one already sees the change of the first one, and so forth. The problem with this model is that it worked well when cores in the same host were like 5, 6, 8. Now that we have basically 60 cores or more, it's no longer scalable. So you can get like a threaded Redis, which is 5 times faster compared to non-threaded Redis, but still to saturate all the cores requires a different setup. So I thought, let's do what we are doing right now. Basically, don't use threads, and instead use a shared nothing setup, which is you just take one instance for each core, and maybe you pin the instance to the core, and that's it. But the problem with that is that currently Redis, in certain ways, doesn't help you to have multiple instances in the same host. So what's possible to do, basically, is to improve this experience of running multiple instances in the same host. What we can do is basically create a Redis cluster proxy, and this also would help a lot with the problem of connection explosions that we have, because in Redis cluster, every client must connect to all the nodes. So if you have like 1,000 clients connected to each node, it's a lot of connections. Instead, also, sadly, we are seeing that a few client libraries were able to adapt to the new Redis cluster protocol, but many lack any kind of good support for cluster. So to have a strong, very good proxy threaded fast for Redis cluster could help in multiple ways. Also, one problem that we have right now is that if you run multiple Redis cluster instances in the same virtual machine, they misuse the disk a lot. Like, for example, the slave starts to, save. Then there is the master with the append-only file, which is logging the new operations. And the disk is so busy that then the AUF rewrite starts also in the master, and they basically trash the performance of Redis because the disk is too busy. So also Redis should be able to improve this kind of experience with simple stuff, like if there are 10 instances in the same host, like if I'm forking and saving on disk, please wait for me to finish and then start and whatever. And also, Redis clusters should be able to scale better from the point of view of many nodes. The original concept of Redis cluster was to be able to scale up to 1,000 nodes. However, the reality is that a few hundred still work well, but as we add more nodes, it starts to struggle a bit. So there is some work to do also in this respect. So basically, the disk optimization will be just a lock file which the instances use in order to coordinate, just to say I'm saving, this is my PID file in the disk. In this way, basically, you can configure different instances with different lock files, so that if your host has basically multiple disks, you can group different instances to use different disks, because two different instances using the different disks can persist at the same time, and that's not a problem. Another kind of threading that instead I really want to have good support for is the kind of threading that allows you to run slow operations on a different thread. For example, if I call the union command between two big sets, it blocks completely Redis. In the Redis Modules API, 1 year ago, I started introducing a new threaded model, so that modules are able basically to run operations on threads. However, and they can do things like, for example, accumulating replies into this blocked client without locking the main thread of Redis. These modules in the attached threaded context are also able to access Redis, but they have a very narrow window to do so, which is when Redis enters the event loop, because while Redis is in kernel space, it's not touching the data structure. So in this window, the module can actually talk with Redis and the key value space. But this is not enough. We need really a key locking model. Basically, the module should be able to lock a given key. The key is at this point owned by the other thread that performs any operation without any contention. And then when basically it's done, the key is already reconnected to the main thread. However, all this should happen without any mutex. And there is a simple design in order to achieve this. Basically, you have a lock table, which is an hash table with the keys locked, and the clients that are waiting for this key. Because, of course, as a key is detached in another thread, if a new client arrives and wants to run an operation about this key, it must be blocked. And finally, the key is unblocked, and the clients are unblocked as well, and so forth. And we want to support read-write locks. So basically, in the case of a slow operation in a given key, which is read-only, multiple clients are able to do the read-only operation thread at the same time. Other than that, there is more cluster changes ahead. For example, one is the sticky slaves, which I implemented a couple of weeks ago, which means that you can have Redis cluster slaves that are not active part of the failover. You say, you are a slave, please don't play in the failover process, never become a master. So if this slave is on a different data center, basically and this works well also. It's a flag which is propagated across the cluster, so all the instances also know that this is a sticky slave, and so it's one of the features. Non-blocking migrate, I have a pull request, and I have to understand if it's good enough. But yes, a lot of work was spent there, and it's interesting for me to review this and merge. Also, the cluster tools are now ported to Redis CLI, so no longer Ruby tools, which were a bit fragile. It's better like that. And also, I want to improve the Redis consistency in one way. Basically, I want an option for Redis cluster that tells Redis when there is a failover. For now, it's a best effort process that we try to select the slave with the best offset. I want to be able to say okay, in the failover, if you cannot reach the majority of the slaves, don't proceed with the failover, so that data safety becomes stricter. However, one of the biggest things that we can do in the next year as a community is to focus on the problem of the client-side caching. Because you can make Redis faster as much as you want, but to go really an order of magnitude better than what we have right now, we need basically the clients to be able to retain the most used values directly in the application side memory. like you have a lot of keys, but there are this small spot of keys which are extremely requested. For example, imagine like a tweet by Beyoncé or something like that. It's a very typical use case. Twitter is very good mental model to think at problems, but you can map the same problem basically to your application. And imagine if these top keys would be in the memory of the clients, the speed up that you can achieve. But in order to be able to do that, basically the server must help the client. They must create a protocol. This protocol is an invalidation protocol because the client can say, okay, I'm caching this value. But the problem is that as soon as the value is modified, the client wants to be notified by Redis in order to see, throw away this value, and this is the new one or whatever. It's a protocol like that. Basically, you request a key. In the reply, we get both the value and also the popularity index of the key, which is at which frequency lately this key is accessed. So the client can already make choices about what's good to cache or not. And then the client tells the server, for example, okay, I'm caching this key. And finally, after 5 minutes, the key will be modified, and Redis will stream to the client an invalidation message. But this is very challenging to get to get right. One is that, as you can see, this is a push protocol. It's like IMAP. You basically want the connection to be like PubSub. You can send commands, but you also can send asynchronous get asynchronous replies from the server. And there are ways to make this. For example, you know when the connection is in PubSub mode, you can still send subscribe commands. But I want to modify that so that you can also send full commands of Redis and get a PubSub message, which is the reply to the command. In this mode, the connection is basically able to send asynchronous messages to the client. Another problem is basically tracking. How we exactly track basically which client has which key. We could use a Bloom filter, or we could have a small radix tree for each client. But there are a lot of problems to solve, but I believe that there is so much value to capture from that, which is a good thing to spend a lot of time trying to fix this problem. And of course, this will be just a protocol suggestion, and then the clients have to implement client-side caching in the different client libraries will get such support. There is other plans that we have. One is basically to change the expiration process of the keys. Currently, you know, Redis, for example, in order to expire keys, it performs sampling on the key space, looking for keys that are about to expire and collecting them and then trying to expire the keys. But it would be very cool if Redis could have like, each key should exactly expire in the moment that the TTL terminates. And it's possible to do that, basically using a radix tree which is sorted by the expiration time of the key, and then the key itself should remember this expiration time. So basically we have a lookup table. We just run the tree which is sorted, and as long as the times that we find are expired, we expire the keys and stuff like that. The trick with that is to do it without using much more memory compared to the one that we are using now. Another interesting thing is to apply basically the radix tree and list packs in all the data structure. Basically, streams are implemented using radix trees and list packs, which is a new encoding which Redis uses internally. But the cool thing is that it's not like the hash data type where you, for example, over a given size, change the representation from a zip list, from a packet data structure to a full-flagged hash table. It's that you have a linked data structure of macro nodes having multiple elements. Streams are like that, lists are like that, but hashes and sets and sorted sets are not like that. It would be great to convert them in this way, and also to convert the main Redis keys dictionary to use Redis tree. Okay, that's all, and I hope to talk with all you in the course of these 2 days, and have a nice conference. Bye.